Hello all, welcome back to Getting Started with Python Machine Learning. So in the last section we talked about classification, and we know that the opposite of classification is regression, and so today we're going to talk about regression, which is predicting numbers in the future. To go over regression, what we're going to do is we're going to take a look at 4 different things. Number 1, creating formulas that predict the future, using a house price example. So you know what this house price example would be. We've saw the Boston house price datasets before. Number 2 is, much like logistic regression, we're going to present to you the simplest regression model, which is linear regression. It's actually even more simpler than logistic regression, where you don't even have the sigmoid function. In the third video of this section, we're going to apply linear regression to the Boston house price task. In the fourth video of this section, we're going to evaluate numerical predictions with least squares. In this video, we're going to talk about creating formulas that predict the future, a house price example. In this video, we're going to take a look at number 1, revisiting the house prices datasets. So this is the Boston house prices datasets that we have already seen, 13 features, and our target is the median house value in that area. Number 2 is I want to show you the importance of looking at what we're predicting. Right? So it's always very important to understand what you're predicting when you're doing machine learning. Number 3 is I'm going to show you a few techniques to visualize the data on the prices. So what we are going to mainly do is, on top of what we have done in the iris datasets, where we looked at the ranges of individual features and their correlation with the label we're going to predict. This time, because we're predicting a number which has a lot more, in fact infinite values, compared to a classification task, we're going to use data visualization to help us understand the relationship between features and the thing we're predicting. So let's go in and take a look. We're back in our Jupyter notebook, and as you know, this is the notebook for section 4. First thing, let's import the Boston datasets. We ran this, and we've loaded it into Boston data. As usual, let's put the data into X, and the target to Y. And we also want to create our data frame. So let me do this first, and then import pandas as pd xdf equals pandas data frame x, and then columns equal Boston data dot feature names. Let's take a peek at the data frame. So the way we do this is dot head, which is the first. We can do 5, I think. So we can see that there are 13 variables, and we know that we can also look at the description of the Boston datasets to understand what are the numbers. So for example here, crime rates, proportion of residential land zoned for lots over 25 square feet, and industry, and Charles River dummy variable. If this variable is 1, then the track bounds the river, 0 otherwise, and so on and so forth. As I said before, the thing that is very important in doing machine learning is to understand the range of our target variable behaves, or what the thing we're regressing on behaves. So we know that it's in Y. Let's take some summary statistics. Let's import numpy to do that. And then let's just see how many we have in Y. And then we can look at, so the max is 50, min 5, average is 2253. Okay, so that gives us a good summary of how the prices are distributed. So let's just also remind ourselves what this is. So we're predicting this, right, thing. So the first thing we want to do to visualize the prices is to first import this package called matplotlib, and that's the standard plotting library that data scientists use in Python. So what we do is import matplotlib.pyplots. So matplotlib, and then we import the submodule pyplots as PLT. So I don't know why all of these libraries need to be shortened, but that's just how the data science community has done. So I'm showing you here so that you are in tune with everybody else. And we can also import this very convenient plotting visualization enhancement called Seaborn. And again, the community likes to shorten this to SNS. Don't really ask me why. I think it's easier for us to then use this over and over again in our research scripts. The first thing to do is to then do seaborn.distplot, standing for distribution plot. So we want to plot the distribution of values of Y so that we understand where the prices are in owner-occupied homes. Let's do Y, SNS, and then what we need to do is the keyword plot.show. And the reason for this is because we need to tell matplotlib to trigger and show the plots, and that allows us to stack up many variables into the plot before we show the plots, instead of every time we call something that sets up a plot, the plot is refreshed, and that wastes memory and time, right? So this is why plt.show exists. So let's take a look at how the prices are distributed. So we can see that our average 22 is around here, so this is where the average is. So as you can expect, the number of houses that are at this price increases until it gets to the average, and it decreases. One of the things we notice that is quite weird is there's a sudden spike at 50, and then there's no values after that, which is quite interesting. One of the things that we know after looking at this anomaly is that actually all houses that are more expensive than $50,000 is marked at 50. So actually this data point is not the same data points as these other data points, because these other data points are actual prices, and this is just like maybe it's higher than 50. So what we need to do is to remove it. In the next video, I'm going to show you how we can remove this and make it a uniform data sets that we need to predict. And that's all there is to it. We talked about the house prices data sets again. We talked about what we're predicting, and then we used data visualization on prices to look at how the overall prices are distributed.